This third lecture video is going to cover very briefly mass, weight, and also accuracy. Mass is the quantity of material making up an object. Mass is measured in grams, kilograms, which is the SI unit of mass, or milligrams, but the important thing to remember about mass is that it remains constant everywhere. So the mass of an astronaut on Earth, let's say it's 120 kilograms, they will still have the same mass on the moon. It will still be 120 kilograms. Again, mass does not change wherever you are. Your mass stays constant. The amount of stuff that makes you up stays constant. Weight, on the other hand, is a measure of the gravitational force or pull acting on an object. So weight is measured in newtons in the SI system, or pounds, which you may be a little bit more familiar with in the English system. But 1 newton is equal to 0.225 pounds. 1 pound is equal to about 4.45 newtons. These are just some basic conversion factors that you may find helpful on some of the homework. And the big thing to remember about weight is that it changes according to an object's distance from Earth or another planet. So your weight is much less on the moon than on Earth, because again, it's a measure of the gravitational force or pull acting on you. So this astronaut that we looked at before has a mass of 120 kilograms wherever they are, but on Earth their weight is 270 pounds, including their spacesuit, we'll say, but on the moon their weight is only 45 pounds. And again, weight is a measure of the gravitational force or pull acting on an object. We'll cover mass and weight in much greater detail in future chapters. But for now we're going to talk a little bit about numbers. So an exact number is a count or a known quantity. So an exact number might be how many students are in a class. 1 hour is equal to 60 minutes. Those are all exact numbers. By definition, there's 60 minutes in 1 hour. That's why we can consider that an exact number. An approximate number is a number that's determined as a result of some measurement process. And the important thing to remember about measurements is that no measurement can be found exactly. It all depends on how accurate your measuring instrument is. So numbers may be expressed in terms of accuracy or precision. So we'll look at accuracy first in this video. In the next video, we'll look at precision. So accuracy is just the number of significant digits that you have in your number. And significant digits are the number of units we are reasonably sure of having counted when making a measurement. So the greater the number of significant digits we have in our number, the better the accuracy. Now, when we are looking at accuracy in significant digits, there's 6 rules that we have to follow. So first of all non-zero digits are significant. So in a number like 244.8 meters, there are going to be 4 significant digits because all of these values are non-zero, so they are all significant. Rule number 2 tells us that all zeros between significant digits are also significant. So if we have a number like 120.08 kilometers, even though we have 2 zeros in here, both of these zeros are located between other significant digits, so both of these zeros are also significant. So this number will have 5 significant digits. Rule number 3 tells us in a number greater than 1, a zero that is specifically tagged or specially tagged will be significant. So when we're saying specially tagged, we're talking that it has a little bar over the top of it. So in this number, 25,000 seconds, the 2 and the 5, those are both non-zero, so they're significant. This 0 is specially tagged, so it is also significant. So that means the 0 to the left of it is also significant because this 0 is located between 2 other significant digits. Now the 0 to the right of the 0 that is specially tagged is not significant because it is not tagged and it's not between other significant digits. So 25,000 seconds, there are only 4 significant digits in this number. Rule number 4 tells us all zeros to the right of a significant digit and a decimal point are significant. So in 75.0 inches, we have a significant digit, 5. We have a decimal point, so any zeros located to the right of that decimal point will also be significant. So in this case, this 0 is significant because it is located to the right of a significant digit and a decimal point. In whole number measurements, zeros at the right that are not tagged are not significant. So if we were looking at 4,500 feet, these zeros are on the right, and neither of them are specially tagged. We don't have any decimal points in there, so neither of these zeros are significant. So that means the only significant digits in this number are the 4 and the 5, so we only have 2 significant digits here. Rule number 6, or last rule, in measurements of less than 1, zeros at the left are not significant. So if we had a number like 0.000456 meters, none of these zeros are significant because we don't have any significant digit out before the decimal point. So again, all these zeros to the left, none of them are significant. The only digits that are significant are the 4, the 5, and the 6, so there's only 3 significant digits here. This concludes our brief discussion on mass, weight, and also the rules for significant digits and accuracy.